Hey guys, so today we're going to talk about piecewise functions. So something finally totally new to you. So let's break down what it means. Piecewise, well, it's got this word piece in it, and it's functions. It's just a bunch of pieces of functions shoved together. That's what it is. We got an example here. F of x is equal to, and we got some curly brackets indicating that it's all this mess. Now, how many things could be up in here? Many as you want. So it could be lots of pieces or it could be two pieces. If it's just one piece, it's not piecewise. So it's at least two pieces. Now let's dissect this thing. What's going on here? So it's f of x, it's function notation. Remember, f of x is the same thing as saying y equals. But we got two different equations it's equal to. So this is like saying f of x equals x squared minus 1. That's this part. And then it's also saying f of x is equal to 5x plus 3. Excuse me. So when do we use this piece and when do we use that piece? Well, you might be looking at it like, oh, what's this stuff over here? Exactly, that's when we use it. So if x is strictly less than 2, so it's smaller than 2, x is less than 2. Oh, my bad. X is less than negative 2. Negative 2. Read properly. My bad. We use this guy. So that's when x is less than negative 2. Our y value, our function looks like this thing, which if you look at it, that's the quadratic. It's got x squared on it. Now, if x is greater than or equal to negative 2, we use this thing. Well, that's a line. It's a positive 5 slope and a y-intercept of 3. So it's going to look something like, well, this guy, it's got a parabola and a line that look like that. So somehow we're chopping these two up and shoving them together. I don't know exactly what it looks like off the top of my head. Maybe you do. I don't know. It could be like something like this. I don't know. I don't know. But it's made up of those two pieces. And we got to evaluate f of negative 5 here. So that means we're plugging in negative 5 for x. So x is what? Negative 5. Is negative 5 less than negative 2? Or is negative 5 greater than or equal to negative 2? That's what you got to ask yourself. Hopefully you realize it was less than negative 2. So that means we're going to evaluate f of negative 5 using this piece of it. So anytime you got an x, take some parentheses and replace the x with them. So it's something squared, minus 1. What's that something? Negative 5. Boom. Then you can use your order of operations or a calculator. That's going to be 24. So I will need to see the setup here. I need to see this. Can't just give me 24. I need to see that you're plugging it in right. You know, if you're using this equation or that equation, I need to see what you were doing. Because let's say, you know, you'd put 26 here, or somehow you got 28 because you put a plus 2 instead of a minus 1 or something. Well, if you have this written out, I'll see that you knew which function you used, so I can give you partial credit there. If you just put the number, it's right or wrong. No credit. No work, no credit. Negative 2. All right, now here's an interesting bit. Is negative 2 less than negative 2? Or is negative 2 greater than or equal to negative 2? Think about it. Is negative 2 less than itself? Nuh-uh. Is negative 2 greater than or equal to itself? Yep. It is in fact equal to itself. So we're going to use this guy right here. 5 something plus 3. That something is a negative 2. Again, use a calculator and you get 7 on the negative side. All right, now 7. Well, hopefully you don't think that's less than -2. It's definitely bigger than -2. So I'm plug it up in here, this linear part. All right, and you get 38. Use a calculator. So to evaluate a piecewise function, the first thing you got to do is figure out which piece you need to use, and that's based entirely on your x, your input. Where x is your input. What am I putting in that thing? -5, so that's going up in this section. Let's try another one. So this guy's got how many pieces? 3 of them. Oh, what's his name? G. What's up, G? Let me get this face of mine out of the way. And maybe over here. That'll work. Okay. So we have 3 different pieces with 3 different conditions. Okay, so let's look. I'm not worrying about anything right now except A. So right here, G of 2. My input is 2. Is 2 less than or equal to -4? Is 2 between -4 and 1? Is 2 bigger than or equal to 1? Yeah, I'm stick it up in there. 2 something plus 9. That something is this 2 right here. 8, 16, 25. Let me use a calculator in case I messed up in my head. I am messed up in my head, right? Yeah, I know you're thinking it. Plus, you might not know how to use the exponential button. It's that little thing. Instead of square, you hit that thing, instead of 3 up in there. Okay, I didn't mess up. Cool. That's A. Now, there's 3 of these, so most likely they're going to be 1 in each section. But don't rely on that. Check each time. -1. Is that less than or equal to -4? Nah. Is that between -4 and 1? Yeah, it is. So I'm going to use this piece right here. Negative something -1. Oh, that's a lot of negatives. That's 0. Okay. Now let's look, -6. That's what we're shoving in here. Yeah, it's less than -4, so I'm going to go with this guy. Half of something plus 3. Something's -6. Hey, look, another 0. Okay, so you just type that in the calculator, or do the math in your head, or probably not in your head, because a lot of times you mess up. I mess up, so you mess up too. We all make mistakes. Use your calculator. You knew it was coming, didn't you? Graphing. So we've been hammering graphing for a while now. It's not going away. Right now, we're just gonna do some lines, linear equations, graphing lines, not lines of other stuff. Yeah. Anyway, we've got these 2 lines. If you look at that, that's a line. Think about what that says. F of x, you remember that's the same as y, so that's like y equals x. That's in slope-intercept form. We got a slope of 1 and a y-intercept of 0. So I'm going to color code these things. This one right here, y equals, again, because f of x equals -2x plus 1, and that's -2. And remember, if it's a whole number, you can always just shove that over 1, and that'll be a fraction, so you can see what your rise and run is. You don't have to write it like that if you don't want to, though. It's up to you. I'm good with an integer, so I'll just leave it like that. So here is the pertinent information for both of my equations. So what I'm going to do is I'm going to plot the dots. I'm not going to graph the whole line yet. I'm going to plot the dots. So starting with the red guy, got a y-intercept of 0, Slope of 1. So go up 1, right 1, down 1, left 1. I'm not going to go all the way because, well, let's look at it. What's my condition here? X is less than or equal to -3. Okay. Oh, that's here, right? So I'm not even going to worry about any of these dots. I just got to go this way. So I've got to actually erase these dots until -3. That's the first dot I can plot. Now, if you didn't want to go through the whole rigmarole of graphing it and erasing stuff, you can plug in numbers. You can point plot. Plug in your endpoint, -3. Yeah, it's -3, -3, right? It's y equals x, so it's going to be the same number. Then you need to go less than or equal to, so you need to go to the left. The left of -3 would be like -4 works. So -4, do the math. If you don't do anything to it, it's still -4. So -4, -4. And you can just see, oh, how my slope's 1. Keep on going. I'll give it a slope there. Lots of ways to do these. So now let's get to something interesting. I'm doing blue one. My y-intercept is 1, so we've been doing it this way. I'm going to keep doing it this way. -2, so that's down 2, right 1. Or, of course, we could go up 2 and left 1. So we're going to need to go to the dots until we're lined up. Now, wow, I messed up that, didn't I? Up 2, left 1. Count properly, please. I didn't. Now let's look at that. You notice something? I see something something's not right here. Because if I were to do this with color, I think there's a vertical line test. That's not a function, is it? And it's piecewise functions, not piecewise relations of some sort. So we got to fix that. Notice it doesn't say x is greater than or equal to -3. It's greater than -3, so that means we can't include -3. You remember how we don't include stuff whenever we're graphing, like on the inequality? That's right, open circle. Parentheses, you would use the parentheses whenever you had a open circle. So you're going to need to make sure you don't have that thing solid. Make it big, make it open, make sure it's like that. If you do have to do solid, for some reason you can't figure out how to not do solid, go back in there and put some white in the middle. That'll work too. Or you can just draw carefully. Just make sure it's not solid. All right, now I'm going to go ahead and graph my lines. This is an equal to. So it's going to be solid. It's no shading. Back to the old way. Just graph the dang thing. So I'm going to start here and go that way. Keep going. I'm going to start here. I'm going to put my line here so I can actually graph it correctly. But remember, it doesn't actually include that. That's why I got to have a big open circle. Your line can't cover up that openness. So I've got an arrow going forever this way and an arrow going forever that way. Let's take a breather. Okay. So that's the same stuff we've been doing with graphing. Slope intercept form. That's not new. The only thing that's new is we got pieces of them. We're not graphing the whole things. Usually you just draw the line and go forever. Here you got to chop off half the line. Not that that makes any sense because line's going forever. You can't have half it forever. But you know what I'm saying. So if we look at this now, it wants the domain and the range. Domain's real easy. You look at your conditions. Is there anything in here that's not included? Well, we got everything to the left of -3 and -3, and we got everything to the right of -3. I think we got everything, don't we? So my domain's negative infinity to infinity. There's nothing that was skipped. Now, the only way you're going to get your range is if you graph it. Obviously, you can do some algebra and get it, but if you graph it. This is going down forever. That's going down forever. So I got forever down twice. Negative infinity for sure. Now, how high up do I go? This is tough. I can't count. 1, 2, 3, 4, 5, 6, 7. This is 7, right? That's the highest point is 7. Do I include that point? That's open circle. I don't include that point. Parenthesis. Interval notation's coming back to you. Can't lose it. Like I said, we're using that throughout the year. So if you didn't catch it before, catch it now. All right. That's it. We got the domain, we got the range, we graph the dang thing. That's it. Keep on going. Let's do a couple more. Wait, I just did that one. Oops. Yeah, we can do this one. Yeah, we'll do this one. So again, who cares what the name of the function is? I guess it does, but we don't care what its name is. It's not important. It's just a function. Y equals. So on this part, my slope is -3, and my y-intercept is -7. What's going on here? This is, if you think about it, basically y equals -5, right? That should be real easy for you. One, two, three, four, five, right here. Boom. If you don't know it yet, y equals a number is a horizontal line. X equals a number, a vertical line. That's y equals a number. Graph it. That's a given. Now we got a problem. It's not the whole thing, is it? What's our condition? It's got to be bigger than or equal to -1. So -1 is right here. So this right here, and it's going to be solid. So I need to ungraph part of this line. Yep. There I go. You can always put white over it, or you can just erase it if you dotted it, you could do it like that or something. Or you can just do it right the first time. Perfectly fine option. Now, I'm going to put my dots for the red one. Y-intercept at -7. Let's say it's 5, 6, 7. Oops. Let me show you my color. Sorry. And a slope of -3. Well, I'm not going to go down 3 now, am I? I'm going to go up 3 to the left one. And I'm going to keep going up 3 and left 1. However, it's strictly less than -1, so I cannot include -1. So here's -1. That's got to be an open circle. And this guy's gone altogether. So now grab the red line. And I'll just go from there and do that. If it sucks kind of like that, it's perfect fine. As long as it's not too tight. There we go. That's it. Now let's look at the domain and range on this one. So my domain, it's going left, it's going right, it's all real numbers. You can look over here. It's going left to -1, it's going to the right to -1, it includes -1, all real numbers. Oh boy. The range. You see what's going on here? It's got this one number right here, and then it jumps. If we put one number, we put that in set notation. That's in curly brackets. What is this one number? -5. Remember, curly brackets for discrete numbers, ones you can count on your fingers. Or That's an amount that you can count on your fingers. It has one answer. It's one number in this part of the range of blue. The blue range is just -5. That's it. So we're going to use curly brackets. Now, it jumps, doesn't it? It jumps up here. So I'm not including any of this stuff. It goes to this number right here, which is -4. So I got to join it. How, you remember that? How do I join something? With a union. It's a U. And I'm going to go -4, but I cannot include it because it's got that open circle up on it. Then it goes all the way up to infinity. Boom. So that range is a little tricky. You'll get it with some practice. Don't worry. And the most important thing is practice on these. Let's do one or two more like that. I'll do one of those, and let's see. That's not really interesting. Okay, doesn't matter. This one's got two. Well, let's do this. Oh, it's not right. I'm old. Let's do this. Hey, that's real easy. I'm gonna color code these things. Oh, red, blue, and how about black? Well, red and black are they're done. You don't have to do anything really. Take your horizontal line and draw them. -1, 6. Well, this one you have to count. Then you fix where it's supposed to be at. It's less than or equal to -5. Okay. I'll take you and you shrink you. -3, 4, 5, right there. Make sure you put a dot on there. It's a solid dot, right? Let's make sure we know it's a solid dot. Did I do that on that one? I don't know if I did. I did. Okay, good. Glad I did. Because you might be having an open circle there. We don't know. We do know because that includes solid. Now the 6, it's if it's greater than or equal to 1. I'll take you, go to 1. Again, it's a solid dot, so put it. And go ahead and put your arrows. They do go on forever. They don't stop unless they stop. Let's look at what's going on here. We got a line. It's got a y-intercept of -3 and a slope of -1, so we could use that. We could. Remember what I was telling you earlier, though? Probably don't. We can just look at the endpoints and go with numbers from there. If it's up in the middle, we got 1, 2, 3 of those, and this is in the middle of them. I'd say just do the endpoints so you know it goes here somewhere, and connect them. So what I'm going to do is the blue line. I'm going to do it doesn't include it, but I need to know this and this would be for this line right here. So I'm going to do negative something -3. What's that something? My first endpoint. That's 2. Calculator. I'm probably going to use a calculator to check myself in a minute. Negative something -3. That something is 1. So that's -4. Let me just go ahead and make sure I don't mess up. Negative 5 -3 is 2. Okay, then that's that one up. Change that to 1, and that should be good. Cool. This as an ordered pair is what? X is -5, y is 2. Open circles. Put it open circle at -5, 2. Then on this one, it would be 1. And then I connect my dots. And then I don't give them title to connect the dots. This thing looks all funky and stuff, but that's it. That's what it is. It's got 3 pieces of line just shoved up on that graph. It's all good. Domain. It's got all these jumps and stuff going on. Does it not include something? Let's look. It's everything less than -5 or equal to -5. It's everything between -5 and 1, not including the -5 or 1. And it's 1 and everything bigger. Oh, we got it all right. It's all got. Now it is possible that it won't all be covered, so you got to pay attention. Just follow it out. Is everything to the left of that? These match. Okay, it's everything between these two and these match, and it includes it, so we're good. Range. So the range is bottom to top. Going from the bottom up here, that's -4 is my first thing, and I don't include it. It's open. Now, where do I stop going up at? Oh, hey, look at this thing. It's just sitting here, but who cares? It's here and it's here. It's irrelevant as far as the range is concerned. It's included in this piece right here. So I go up, up, up until this little piece right here, which is 2. And again, I do not include it. So this is the interval -4, 2. Everything between -4 and 2, not including those two guys. That includes -pi and weird stuff like that. It's everything from here, from here to here vertically. And we got to jump. And we go to this one number. One numbers again are in set notation. Or if this was over here somewhere, we'd put that in a set notation too. We could have 2 set notations, that's fine. Or 3, or how many ever, it depends on how many pieces we have and where they're spread out at. We did not need it here because this range is covering this guy right here, so we didn't have to worry about it. Let's finish first. This is at 6, right? Yeah, 6. There we go. Okay, let me do one more. Let's see, which of these is more interesting? I think this one is. They all have the conditions on. Yeah. Let's go with this one, number 8. Okay, here we go. Here we go. Get ready for this. Okay, you're going to be blue. You're going to be red. You're going to be black. Now, for the middle one, I'd say just do the endpoints. The other guys, whatever's easier for you, you can point plot. I'm going to do that for you. I'm going to do that. So here's a pretty methodical way to do it, I guess would be a good word. -3 and plug in your endpoint. Is this endpoint included? No, it's not. But we still need to see what this would be if it was included. What would that be? 0, right? So we have 0, 0 as a point, but it's not included. To graph a line, I need 2 points, or a point in the slope. Oh, I got my slope. Well, which way do I want to go? I want to go less than 0. Just to the left. So I'm going to go up 3 and left 1. That's going to be solid. Everything past this is solid. You could also have plotted another point. So I need to put a number to the left of 0. That would be, how about -1 works. 3. So I could plot the point -1, 3. Oh, hey, look, there it is. I already did it. Oh, because I used my slope. You'll get the same thing either way. Your choice. All right, so that's my blue guy. Blue is done. Let's look at red. It's in the middle. We got more than one more. You can have more than one function in the middle. You can have 4 of these things, and both middle ones I do the same way. I like to just plot my endpoints. Point plot. You've done that for so long, you know how to do that. Plug in 0, plug in 6, see what's what. -1/2 times something, -1. That something is 0. Oh, that's easy. -1. I got 0, -1, and look, we include it. 0, -1, inclusive. Then I'm going to plug in 6, because that's my other endpoint. Let me double check myself there. I think it's -4. Almost 100% sure it's -4. If I'm wrong, I'll be angry at myself. Embarrassed. Let me not embarrass myself. Okay. So 6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That one's open. So this had a solid dot and an open dot. Well, open circle, I guess. I don't like how close that was. So put open circle. Now I can graph my red line. I'm going from here to there. There we go. Of course, you could have started with some point. -1's y-intercept, slopes -1/2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Yep, that matches. Cool. So there's multiple ways to do these. Whatever you're most comfortable with. And again, I'm going to plot my endpoint. So something, oops, let me check the color. Something -7. That's something is 6. That's -1. 6, -1 is my ordered pair. Plot it. And that is open. Open. Interesting. 6, -1. Open there. I've got a slope of 1, so up 1, right 1. Or of course you could have just plugged in another number. How about 7? 7 by 7 is 0. Hey, look, there it is. 0. Glad I did this one. It's got an arrow going off over there too. Okay. Domain and range. Let's talk about it. Okay, I'm going to look at my. You might see it already. You might. I'm going to look at my conditions here. Everything less than 0. Okay. So I'm going to start by writing that down. We go left to right in our range, or a domain in our range anyway, so it doesn't matter. Negative infinity. That's where we're starting. Up to 0, including 0. Okay, 0 is good. So we're going to go 0. We also go up to 6. But look at that. Neither one of these includes 6, do they? We got to stop at 6. We don't include 6, so we're going to put in parentheses. And we're going to do that again. And it's everything bigger than 6, right? It's every single number in existence except for 6. Every real number. Let's go with that. All real numbers except for 6. That's my domain. And that is how you write it. My range. Look at the picture, people. There's just no way to do it. Well, there's a way to do it without looking at the picture, but if you use the picture, otherwise you're just going to mess it up. So bottom to top, I'm starting here at -4, and I do not include it. I go up until, well, that's included. I go up until this dot, -1, but I'm going still up from here, and I'm going up forever, aren't I? So even though it jumps right here, it's still, the y value hasn't changed. This is -1, this is -1, and it keeps on going. So is everything bigger than -1? Is everything smaller than -1 up to this point, -4? So it's going up forever, infinity. Huh, there we go, that's my range. Yep, that's it, we're done. So it's not really anything too new. It's just taking a whole bunch of stuff we've been doing and shoving it together. Graph lines, more than one at a time. Well, we've done that before too. All right, that's piecewise functions, guys. We're going to call it right there. See ya.